Welcome. In this video lecture, we are going to use an example to show how to create a geologic cross-section from a geologic map. So up top here we have the geologic map, and I want you to notice a few things about it. So each of the different colors represents the surface expression of a different type of rock. Right, the one that I've circled is this sort of almost purpley one. It's present on two different places on the map, is where it has surface exposures. It's called the Devonian Shale, okay? And the letters there, even in the absence of the words, the letters should tell you that that is from the Devonian period, which if you pull out your geologic time scale, you ought to be able to see Devonian period and know whether that is before or after the Silurian and the Ordovician periods. And that can sometimes give you a little bit of hint when you're trying to figure out the geologic formations that exist under the ground. Now, anytime you need to make a geologic cross-section, and it is much easier to do this on paper, what you want to do is, so we're going to make our cross-section from point A to point A prime. So what does the ground look like if we could just slice this and take a side view of it right there? So the first thing that we need to do is recognize on this lower bit, which if I was doing this, not on the computer, that would be a separate piece of paper in a lot of instances, but sometimes lab activities and such will have this little drop-down box for you. So here, the actual location of A is right there. The actual location of A prime is right there. And the first thing that you need to do is to get the locations of all of the contacts between two different rock types onto the map. So the contact between this Devonian shale and this Silurian sandstone is right here. Erase some of that. Right here is that contact. So I need to make sure that I put that location onto my cross section. And then I go looking for the next contact, and there it is. So I make a dot or a dash right here on my cross section, and so on for all the rest of them. You just want to mark those exact locations on your cross section until you have either a little line or a little dot for all of those contacts. Okay, I'm going to erase all of those so that I can do this cleanly, since they're already there for me as little dots. Okay, so next thing that I need to do is I need to know how the material is dipping. I'm lucky. So if I look at the map, this symbol here tells me the strike, and the little bit coming off the side, that tells me the dip. So I know that this is striking north-south. That's what that line there tells me, combined with this north arrow, right? That's the north direction. So it has a strike of north-south. If I was literally to walk around here, I would see a break in the rock oriented north-south with one type of, on one side, I would see the sandstone, and on the other side, I would see a limestone, okay? And then the little knob coming off the side, that tells me the dip. In this case, the dip is 45 degrees, okay? So that means that the beds are dipping outward away from the limestone, right? So this one's our limestone, which I know just from reading the key over here. And the dip is away from the limestone. So what I want to do is actually put a line on my cross section. Now, if we were in class, we would be using drawing compasses to get these angles perfect. As it is, we'll just have to make do with freehanding. And we have 45 degree dip here. And on the other side, it looks like we have a really similar contact dipping the other way. represented by that symbol. So I'm going to try to draw in a 45-degree dip over here. And I don't have any data for any of the other contacts, right? So I'm just going to have to fill in what makes sense. And it makes sense given the fact that all rocks are originally horizontal, so they should be sort of parallel. These are all sedimentary rocks, shale, sandstone, limestone. And so when they fold, they're still going to be parallel. So I'm going to go ahead and draw in some of these other layers just in a way that makes sense. So the fact that I had these two contacts dipping outward told me that probably all the other contacts are also going to be dipping outward unless I have evidence to the contrary. So what feature are we seeing here? Hopefully you can tell that this is an anticline. So right now I'm drawing in some layers above. So below ground where I'm fairly confident, I made those solid lines, and above ground where the material is actually eroded away, I drew in the fold that sort of used to exist, and I did that with dashed lines. Now the other thing that I would want to do here is to get my colors straight. So it looks like the middle layer here is designated with some sort of a brown color, so we need to color that in. Yes, coloring is mandatory in geology. If you don't have access or ability to color, use cross-hatching or whatever you can to try to differentiate the different layers. It actually really helps when you go to make interpretations. If you have the colors, it lets you see much more clearly what connects and what doesn't. So for example, here my limestone is in 2 locations on either side of this fold. Okay, and then the final, well, I guess I should fill this out a little. Yours should be quite nice. I'm just trying to go a little fast because it's a video. Okay, yellow. Oops, that's not yellow. Yellow. On the sides here. And the final one looks like this sort of purple out there. And there you have it, a cross section. All that we've done is, well, the first step is to map all of those contacts onto your map. And then you need to figure out what the dips are, and then extend those underground and color in your different horizons. Okay, so if you have any questions about this at all, please just shoot me an email. We can set up a Zoom. I would love to see your maps as you are making them and give you any pointers that you might need. So with that, I will, you know what, I'm going to show you on another slide what this actually looks like if I had the perfect colors, and then we'll finish up. So actually, for completeness, let's just go over all of it one more time. So step 1, project the contact lines onto the topographic profile. These are the red dashes being used to project those contacts, the exact location where the map view is showing you go from one rock type to another. Project that exact location onto your topographic profile. Next, you draw in the dips with a measurement device if you have one, but this semester it's fine, you can eyeball it. And so the dip is relative to horizontal, not relative to the actual surface here, right? So there's the surface, but the dip angle is relative to horizontal. This is my attempt at a horizontal line. And so this here angle is 45 degrees, which also is equivalent to having the angle down here be 45 degrees. And so that is step 2. You project all of these all of the dips down that you can measure. And then step 3, project other contacts into the subsurface parallel to the contact lines you've already drawn. And then you color. This says if desired, but it is definitely standard practice to color these. And finally, you use dashed lines to project the geologic contacts above the land to visualize the part of the structure that has been eroded. And at this point, it should very clearly look like a fold. This one is on anticline. All right. Let me know if you have any questions.